Hey everybody, there was a quick question that came in about something that happens in regression, and so I thought I would clear this up. Let me first say that the sum of squares, which is what this is about, is something that is not important to us as we're only investigating simple linear regression. The sum of squares residual as well as the residuals in general, and some of the other things that you might find out there are useful when you are trying to compare different models. So you can imagine having several explanatory variables like age, health habits, exercise, blood pressure, all these kinds of things, maybe to predict life expectancy. Um, and you can form different models using those varieties of variables in different ways. And so examining which model is the best fit is a little more complicated than what we're doing, as we're only looking at one explanatory variable. So we don't really have the need to go into that. However, it does show up on your homework, so I thought I would show you a quick video on where that number is coming from, how you can get it, and how it already is in the output that you have. So first, let me just show you something real quick. If we go to the regression, simple linear, and we graph this, so the graph comes automatic in the second picture. The residual is the vertical distance from all of your points to the regression line. So basically what that is, it's how far off the model's the red line, the regression line, how far the model is off for all of your data points. So here you can see that we have a small residual, here even smaller, and then over here these are a little bit bigger. So the residual is important in that it tells you how far off your model is from all your data points. Now, if you find the residuals of all of your data points to the model, and then you add those up, you're going to get 0, and that's true for any model. So summing the residuals is not beneficial because you always get 0. But one thing we can do is you could square them. You could take the absolute value of them. The general process is to square them to get rid of the negative, and then we can add up what those are. So I'm just going to show you how to do this by hand first, and then I'll show you that you already get it in the output. So here I'm going to get it to save the residuals. So there are the residuals. Those are the vertical distances of the y values versus the predicted y value for each one of these x's. Again, that graphically, that's just the distance from the dots to the red line. Now, again, notice if I add all these up, I'm going to get 0. So what I'm going to do is I'm just going to take all my data values and I'm going to square them. So I'm going to take my residuals and I'm going to square them, raising them by a power of 2. I get those there, right? So now I have my squared residuals, and then I'm going to sum the squares, right? Just simply means add. So I'm going to, one more time, I'm going to take my residuals, and I'm going to sum them. So I can actually just hit sum, and then take my residuals squared, and it's going to add those together. And then there's my sum of squared residuals, right? A lot of times this is written as SSE, which is sum of squared error. There's an email you can take a look at. And so you can do that by hand if you want. However, once you do the regression analysis in StatCrunch, you get that number for free. So if you come down here, it's your sum of squared error. So sometimes you might see it in the Google sphere as SS sub E. That's your sum of squares error, which is the same as your sum of squared residuals. So there's how you compute it. I don't want you to get too caught up in it, but I know you want to get through the homework, and I know a lot of you like to get all the questions right on the homework, which is fine. If something like this shows up on the exam or a quiz, don't worry about it. Just skip over it. Shoot me an email, and I'll be happy to give you credit for that. Guys, I hope this helps. If I can help with anything else, don't hesitate to reach out. I look forward to hearing from you. Thanks.